Now that we've got our constructor going, let's continue building these methods. I went ahead and built the toString method. I don't use it, and I don't know why I would, but in case your professor does, you have one here. And I recommend that you ask your professor how to use this. There might be something that he wants you to do specifically, but for this tutorial, I won't be using it, and I hope you don't get penalized for it. So let's continue on to add row. I'll get to shake later. I'm going to do add row and add column. And what this does is that it does as it sounds. It's going to add the rows and add the columns one by one. So this is row 0, row 1, and row 2. Row 0, I needed to just simply add 1 plus 2 plus 3, giving me 6, and so on for the rest. And the columns, I need to do the same thing. 7 plus 4 plus 1, give me a total. 8 plus 5 plus 2, give me a total, and so on. So this is what the add row and add columns will do. As far as the argument, I will be using these arguments as the position of that particular row. So I'll pass in a 0, a 1, or a 2 inside of it. So, and since these guys will be returning just one value, they will be a non-void function of type int. Here we have int add row. Have RR in there like it says. And I'm going to have a container. I'll call it total equals 0. And I'm going to be using the two-dimensional array to play around with. So that means I'm going to need 2 for loops. And I'll start at I equals RR. So this will be my row. If I pass in the row 0, I will start at 0. If I pass in 1, I will start at 1, and so on. Okay. And I don't want it to move. So as soon as RR becomes more than 0, or in this case, more than, if it becomes 1 more than the original, I don't want it to do anything. So I'll just do RR plus 1, and it'll be RR, oops, it'll be I plus plus. And now for the second loop, to do the other dimension, I'll use j equals 0, j less than n, j plus plus. And here, all I got to do is fill my container, let it accumulate with whatever value is in the array. Okay. So you can see this is not growing at all. If this comes in as a 0, I want this to stay at 0. I don't want it to go anywhere. It'll say I equal to 0. And then as soon as as long as I is less than 1, accumulate it. As long as is less than 1, do this. And this will carry out however many times n is. If n was 3, this will loop 3 times, which means it's going to add 3 numbers as we've listed here. So these are 3 different numbers every time it enters the loop. And then once it's done with that, it sees that, oh, I is now not satisfying this condition. It's going to kick us out of the loop where we can return our total. Okay. So let's go ahead and make sure that this function works with this method. And I'm simply going to do a system out. And I will say this is row 0. And I'll do object.add row at index 0. Okay. Here we go. Very nice. Row 0 is, in fact, 6. And just to confirm that it does work for the other rows, sure, we can do a quick test run of the other rows. We have 0, 1, 2, 0, 1, 2. Okay. Yep, this is 15, and this is, in fact, 24. Perfect. So now we got that going. We're going to use the same logic, but this time we want to be in the columns. Similarly, I'm going to pass in an argument, and this time it's going to indicate the column. So I need, if I pass in the number 0, I need the column to stay at 0, but the row will increase by 1. Okay. So you'll find that it's going to look extremely similar to the add row, but I'm just going to change just to CC. And now I want the I, so in other words, I want the row to increase by 1 each time. This will be less than n. But I want the inside or the column to grow, or rather not grow at all. So this will have CC plus 1. So I don't want this to move. Okay. This is going to move however many times n is, however large n is, and this is not going to move at all. Once it hits CC, so if CC is 0, it's just going to stay at 0 and do its thing. But this is the one that will change. Okay, so let's make sure that works. And in fact, I'm just going to copy this out and change this to calls. Change these to calls. Okay. And there we go. So this is indeed 12. This is 15. And this is 18. Great. So now we've got our add calls and add rows ready to go. Now we got to figure out this add diagonal part. 159 and 357. Okay. So the idea is pretty similar to what we did. And we're going to be manipulating with the two-dimensional arrays again. And it will look something like this. Again, it's going to return an int. I have my container ready. And I'm going to do the for loop twice again. Okay. And here is where it starts to differ. I need, so diagonal 1, it's going to go, let's see, it's going to go from left to right. I want to start from index of I on the outside. So this is the row. So remember, I's are the rows and J's are the columns. So I wanted to start at index 0. And the first number here, this is 0, 0. And then this is 1, 1. And finally, this is 2, 2, right? So we're going to come up with a loop that increases that way. We'll have 0, 0, 1, 1, 2, 2. Okay. And how we do that is we set our j to I. And as long as j is less than I plus 1, we're good to go. Okay. To dim I and j. Let's see the same thing here. Okay, so let's dissect this a little bit more. I have my I equal to 0. Great, I'm here at number 2. Okay. And this is going to go until, since n is 3, it's going to go until the number 2. So 0, 1, and 2. So remember, the i's are the rows 0, 1, and a 2. Okay, so imagine I'm starting at the very beginning, 0. Okay, I'm here. And then this one, when j is equal to I, so j is equal to 0. Okay, j is equal to 0. And j is less than I plus 1. So I don't want this to move. Then I need just 0. So j is equal to 0. So I is equal to 0. J is equal to 0. So 0, 0. Perfect. So that's a 2. All right, let's add the 2 to our container. And then this doesn't go anywhere. This we'll see, oh, make sure that j remains within I. As soon as it go I plus 1, it doesn't meet this condition, kick me out of this for loop. So kick me out of this for loop. Now I gets increased to 1. Okay, so now I is 1. Great. I go into this for loop, j will equal to 1. Okay, so I is 1, j is 1. So 1, 1, I got a 5. Add that to my container. I'll do it one last time. Now I is 2 and j is equal to 2. Stay at 2. I got 2, 2, and I got this. So 2, 5, 8 gets thrown into my total, accumulates it, and it returns. So in the context of our table for now, let's see what that value is. Okay. I will go ahead and do this. Call it die1. I don't need any arguments for this one. Add dig1. Okay. Let's check that out. So dig1's 15. Great. 1 plus 5 plus 9. Yep, that is exactly 15. Okay. So now we just got to do the same thing for diagonal 2, 3, 5, and 7 going this way. Okay. And you'll find that it's pretty similar to what we have. But now we got a problem because if we're going to start from here and we go backwards, we got to do decrement. So we got to start from the end and work our way down. So that's going to be a minus minus. Or we could do it this way. Start here and go up. Okay. So we'll go ahead and come up with the logic to start from the end, the top right, and work our way down to the bottom left. And that's going to be called int add dig2. Same thing, I'll have my total. And this time, since I want to start at the end, I want the index to be whatever the length is of this particular row. The length of all rows is obviously 3. And since the index starts at 2, because it's 0, 1, 2, that means it's n minus 1. So I'm going to have int. The starting index will be equal to n minus 1. Okay. Let's get my loop going. I less than n. And here's the tricky part. I have my j. I'm going to start it at index. And I want j, as long as j is less than whatever index is plus 1, then I'll let it continue. Okay. And I will do the total increment here. Okay. But here's the difference between this and that one. I'm starting at index n minus 1, which is all the way at the very end. Since I need to move backwards, I'll make my index go down by 1. So I'm starting index 2, and then I want it to go to index 1 and then 0. So over here, I will simply decrement it, decrement my index. Okay. So I'm starting at index 2. Give me that number and don't move. And then decrement it one time. Now I'm going I second row. And then now I'm at index 1. Give me that number, which is 5. And then decrement my index. Go back into the outer loop or my row. Now I'm at index 2. Oh, sorry, row 2, which is the last row. And give me the index of 0 at j, which will be 6. Okay. Let me return that total. And let's make sure that works. Okay, here we go. It just so happens that it's also 15. Let's make sure. So I've got 7, 10, 15. Yep, 3, 5, 7, 15. Excellent. So now that we know that all of these work, we can continue on with the other methods. And I'll continue that in the next one.